Okay, in this video, I'm going to use Sage to show the following fact. So A4, the alternating group on 4 letters. So this is a group of order 12, and it has no subgroup of order 6, even though 6 divides 12. And compared this to what Lagrange's theorem says, I mean, it's not a contradiction to Lagrange's theorem. Lagrange's theorem says that if there's a subgroup of a group, then the order of that subgroup has to divide the order of the larger group. But it's not saying that if you have a number that divides the order of the big group, like 6 divides the order of the big group 12, it's not asserting the existence of such a subgroup. And that fact is in fact not true, as this example A4 shows. Okay, so let's show this by making A to be the alternating group on 4 letters, and then ask what is the order of A. So that's 12 as expected, 4 factorial divide by 2. And then A dot subgroups just lists all the subgroups of this alternating group A. And it's a little bit hard to read the output, so I typed typeset mode and then asked A dot subgroup again, and maybe it's a little bit prettier, but still a little bit messy. But okay, there's a whole list of subgroups, and I want to know the order of all these subgroups. And well, let's collect all these subgroups into a list, or rename the output in this line up here. And so I collected or formed this list called subgroups, S-U-B-G-W-S, GPS, sorry. And then, okay, that's a list. And then if I want the first element, again, Python starts numbering from 0. So I get the identity, or the subgroup generated by the identity, which say just writes like this. So that's the first element in this list. And anyway, okay, so now I can go through my list by a for loop and just ask for the order of each subgroup. So here's this for loop for S in this list subgroups. Don't forget the colon. Then ask for the order of S using the order function or method. And there we have it. Here are the lists, and we see the list of sizes or orders of the subgroups of A4, and 6 does not appear. A little bit more compact way to use, or sorry, to write the same thing in form of a list is to use, the Pythonic way of defining some lists. So square brackets to define a list, and then s.order for S in subgroups. That gives this list of sizes or orders of the subgroups. And we see again that 6 does not appear.